Algebra, Chapter 1, Lesson 8, and we want to take a few moments to talk about some reasoning strategies or things that you can do to help you conquer the mathematics that we'll be looking at this year. And in your textbooks, it goes through some problem-solving guidelines, which I'll kind of break down into an outline form here in just a minute. But I want to talk a little bit about what I've noticed over the years that I've been teaching math and some of the things that I've noticed where students seem to struggle the most. And one of the reasons, or one of the things I've noticed that they struggle the most in, is that generally speaking, there isn't any time given to thinking about how I'm going to do the problem before students just jump in and start doing the problem. Most students have kind of gathered that math is about numbers, and so when they look at a problem, all they do is look for numbers, and then they just start multiplying them or adding them or subtracting them or dividing them or whatever we were doing in class today with numbers. That must be what I do. And so especially in word problems, we don't even read the words. We just look for the numbers, and then we just start multiplying them and see if that comes out with an even answer. And if the answer is even, it's probably right. And if it's not even, well, I must not understand how to do this. And so there's really no time given to thinking about, well, should I even be using these numbers? Are these numbers even important to me arriving at the answer? As we get into more complex levels of mathematics, in many cases, they'll give you numbers either in a diagram or in a word problem that you don't even use. They're just there as information to help you see the whole problem. But when it comes to calculating your answer, you'd never even use them. And so if you're of the mind that I just take numbers and I use them all and that's how I do math, you're going to have trouble because you're going to be using numbers that you don't need. Many times we've seen students who just, I'll ask them, well, why are you using that number? Why are you adding that number? And it's just like, well, it was in the problem. I figured I have to use it somewhere. Well, that's not how you do math. That's just, you know, having a procedure in mind, something you learn. Well, if the number's in the problem, I have to use it. And maybe that's the fault of the way questions are worded coming through the elementary schools or coming up into the upper levels. There's too much of, oh, we only give you the information you need, so a student's trained to think, well, if they give it to me, I must have to use it. And so maybe that's a problem on our part, but it's something we have to kind of break a habit of, and that is just jumping in without even thinking about what we're doing or just assuming that because a number is given to me, I must have to use it somewhere in arriving at the answer. Another thing that I've noticed is that students always think that answers have to come out evenly. And somehow they think if the answer is not even, I must be doing it wrong. And again, that may be a product of just always giving you answers that come out nice and even, and maybe we need to do a better job of making sure answers don't always come out even, and so you get confident in the mathematical process, and that's what you're confident in, rather than, well, I'm confident this is right because it's even. And so, again, that's something we want to kind of try to break our habit of, is not just assuming that an even number, something that comes out even, is the correct answer, and something that comes out maybe as a fraction or as a decimal isn't necessarily the correct answer. So we want to be able to then also, I kind of started something, but I want one more thing I thought of I wanted to say. Another thing I've noticed is that many students will give an answer and never consider whether the answer makes sense or not. They'll just do the math once and they'll come out with an answer and say, well, I did what I think is right, that must be the answer. And I come out with some really strange answers, you know, when we're asking, you know, if you invest some money for so many years, you know, how much money will you have left? And sometimes I get answers where you have less than you started with, or you can have, you know, a decimal. I mean, you invest $10,000 at 7% interest for 8 years. How much will you have after 8 years? And I get something like 5 cents. The lights just went out. Hang on. So obviously, an answer of 5 cents, if you're investing money wanting it to grow, that answer doesn't make any sense. So we should say, well, wait a minute, that answer doesn't make sense. Let me go back and check my work. Or something, you know, maybe on the other side where, you know, you invest the money at 8% for 10 years and somehow you end up with $3 billion. Oh, wow, that's an investment I want. And so the answer doesn't make sense, but a lot of students won't take the time to consider if it makes sense. So that's kind of what some of these strategies talk about. So let's go through them real quickly and kind of break these down and keep these in mind as you're working your problems and going through, because they are meant to help you become better at math. So the first thing you want to do is take time to understand the problem. Ask them, well, what am I being asked to figure out? Is the information that I'm given, is that all I need? Do I need all of it? Or do I have to go find some other information somewhere else? So did they give me enough information to do the problem? Does this look like something I've done before, where maybe it's not exactly right, but it looks very similar to something I've done before, so maybe I can start there and figure out where I need to go from there. And what I want you to notice in this first part of understanding is that you haven't made any calculations yet. And most students don't take the time to do this. You've got to take time to think about what you're going to do before you start. All right? Once you think about what you're going to do, how you can do it, you can then begin to think about, well, what kind of answer should I get? And then that leads into that last part where, does the answer make sense? So take some time to understand what's being asked in the problem. Once you kind of understand what's being asked and the information that's given, then you want to develop a plan and carry it out. And again, you want to think about, well, what have we been working on? What are some strategies that I need to use? And again, as you work through a homework assignment, usually the beginning problems deal with only the concepts that you've been working on in that lesson. As you get to the more complex problems, really the only thing that makes them complex is that you have to remember something you did in previous lessons in order to finish out the problem. So understanding what you might need to use to solve the problem, and then how can I correctly carry those out. And again, this is all thinking about what I'm doing before I even start to make any calculations. So we've got to develop the plan, and then that's when we actually start making the calculations and figuring things out. Finally, then, once we've figured out what we want to do and we've set up our equations, then we can go ahead and figure out the answer mathematically and then check our work. And so we want to look, is the plan I chose working for me? If it doesn't work, well, maybe my plan's not right. I might have to go back and adjust my plan. What is the determined answer? Did I get an answer? Is the answer reasonable? Does this answer make sense as to what I was asked? And you can't figure out if the answer makes sense if you didn't first figure out, well, what are they asking me to figure out? So that planning process really helps me figure out if I've even come close to answering the question, but if I've never taken the time to think about it, I'll never know if my answer makes sense. And then finally, is the answer stated clearly? For the person who's looking at the answer, does the answer make sense? And this is talking about making sure that our answers have units or we explain them out. In other words, if I have multiple answers, making sure I identify which answer goes with which question that was asked. So making sure that the answer is stated clearly. So all of these things working together help us become better at mathematics, help us become better at expressing our answers and solving problems, and really without these, math is just going to become more difficult. So slow down and take the time to work through these issues and to work through these problems before just jumping in and trying to get to the answer. And then you'll find that your math, you're becoming better at math, and you're becoming better at explaining what you're doing and explaining to someone else how you arrived at the answer, what the answer is, and then defending your answer and saying, this is why the answer makes sense. So take some time to work through these strategies, and you'll be much more successful in your math endeavors.